Good morning, everyone. Today we will continue where we started for this module 8. So, module 8 is under section 4, Inferential 2. So, let's open that and let's get started. So, today we will continue with chapter 4 and where we stopped last time, or what we have talked so far in chapter 4 is talked about the categorical variables, and we talked about how we can apply descriptive statistics for categorical variables, and we defined or we identified that there are two types of categorical variables. We said there is a nominal categorical variable and there is an ordinal categorical variable. And we say that in order to apply descriptive statistics for categorical variables, we will need to report the frequency, means the count, as well as the percentage or the rates or the percentage for each. For example, gender. If we have a gender, we have two categories for gender, males and females. So we will need to report the frequencies, means the counts, how many males, how many females, and we will need to report the percentage of males as well as males and females percentage. So that's how we decide about the application of descriptive statistics for categorical variables. On the other hand, we also talked about inferential statistics for categorical variable. And we say inferential statistics is used when we want to make a conclusion about a population based on a sample. And we use the hypothesis testing steps, and there were five hypothesis testing steps. The first one was to identify the hypotheses, the null hypothesis and alternative hypotheses. The second step was to decide on the alpha level or the confidence level. In our case, we said the rule of thumb for alpha level or confidence level is 0.05. That's the rule of thumb. The third step is to decide which test we should use, which t-test or test statistic we should use. So which test statistic we should use depends on the type of the variable and what we really want to do. So we said when we want to find if there is a relationship between two categorical variables, then we will use the chi-square test. However, if we have one sample and a proportion from one sample at hand, and we want to find out if there is a difference between the sample proportion or rate that we have at hand from a standard rate or proportion that is somewhere else, if we want to compare or try to find if there is a significant difference between a sample proportion and a standard proportion, then we will use one sample z-test for proportion. So that was the third step. So the first step, identify the hypothesis, null and alternative. Second step is to decide about the p-value or the alpha level, which we said it is going to be 0.05. And then the third step is to identify which t-test to use, and depending on the scenario we will be able to decide. And then the third step is to calculate that t-statistic and compare it or convert it to a p-value, and then the fifth step is to make a conclusion. So we said if the p is low, the null must go. So our conclusion will be based on the p-value that we will calculate in all the tests that we will be working on from the starting of the inferential statistics all the way until we finish this class. So based on the p-value, we will be able to decide whether to reject or not reject the null hypothesis. So that was kind of everything that we have talked about in a nutshell. Now, or today, we will continue talking about inferential statistics for categorical variable, but today we will introduce a new concept, confidence interval for proportion, and we will also look at and study two sample two sample actually z-test for proportions. So we will have two samples instead of only one and compared to a standard. Today we will have two samples in our hand when we want to compare them and we want to see if there is significant difference between those two proportions or not. But let's start with confidence interval. So from its name, confidence interval means there are two intervals. There is the lower interval and there is the upper level interval. So in this case we will be able to calculate those intervals. So, and usually there is a range for those values for the interval, and as you can see that there are what we will call it the confidence interval is used in so many day-to-day applications that we have maybe heard in the news. Nowadays there is presidential election and candidates, they have approval rates and polls rates and so on. But whenever there is a poll or there is approval rate reported, they will report with a margin of error. Basically that margin of error or the interval, when we say, like for example, the President Obama's approval rate is 60% plus minus 5%. So that plus minus 5% is also called a margin of error. That means it can be the true approval rate, it can range from 55 to 65. So because that's plus minus 5. So now let's continue and see what else is there. As you can see here in this bullet, the widest confidence interval is 50%. That means a proportion will be, let's say 50, and then plus minus 50 means it can range from 100% to 0%. So that's the highest confidence interval that we can find, or the margin of error can be at highest at 50%. It cannot be more than 50% margin of error. So we need to keep that in mind. So how can we make sure that we are more accurate in our proportions reports? Is that the larger the sample size, the better or the more precise our estimates of the proportion will be. So that's why we need to always make sure that we collect a large sample size, a large enough sample size in order to be precise in our estimation. So confidence interval, actually they are represented in this formula. So P, that means the proportion or the rate for the sample, plus minus critical value for confidence level, and the critical value, we will look at that based on the P value. So if it is two-sided or one-sided, then we will be able to determine what that confidence interval is, or the critical value for confidence level will be. So if it is two-sided, then the basically the critical value will be 1.96. So let's look at this one here. If we have a confidence, let's say the p-value of 0.05, but it is two-sided, that means we will divide it by 2. Then it is the alpha level will be 0.025, and the critical value is equivalent to the 0.025 is 1.96. So that's where we came up with this 1.96, because we are assuming that it is two-sided and the critical value for equivalent to 0.025 is 1.696 here. And then times this square root of the sample proportion times 1 minus the sample proportion divided by the sample size. So now let's look at this example that we have covered in Monday's lecture. So on Monday we said that there is a company that has a compliance rate, the goal for the flu shots or vaccination to be 85. So that's their goal, compliance rate to be 85. That's their standard proportion or rate. However, they hired you as an analyst and you collected data from 10 employees and you found out that only 70% of your sample reported to have had vaccination for the flu. So now we want to calculate the confidence interval for that particular case that you had. Now, as you can see here, we have two-sided. That's why we used, so 70.7, that was the proportion, the sample proportion or the sample rate that you found, right? And then plus minus 1.96, that's the critical value, which is equivalent to 0.025 because we have two-sided. We divided it by 2. And then you multiplied, you use this formula actually to calculate plus minus. For us, we have a calculator that is provided to you in the module. So if you click on this one, you will find the calculator. And actually, I already have it for you here. So the calculator here for confidence interval, we can apply this actually for this example that we had. So we have a sample proportion. So the sample proportion that you collected was 0.7, or the rate for the sample was 0.7. The standard for the company was 85, right? 85%. And now the sample size that you collected was 10 employees. And then the critical value, will keep it there. Now, as you can see, that we came up to the upper level and lower level confidence interval. So now we can interpret these results by saying that based on the sample, we are 95% sure or confident that the true population rate, or in this case, flu vaccination rate, compliance rate, is between 42% and 98%. So that's basically how we we interpret this result. So you can use this conclusion here. Based on the sample, we are 95% sure that the true flu vaccination rate for the company, for all employees or for the population of the company, is between 42% and 98%. So it is very straightforward, simple. Now let's do an example here. Let's work on this example here. Based on the previous exercise, in which we said routine discharge rate for the sample with DRG 293, compare that to the United States standard, which means the routine discharge rate for the US. So they want us to calculate the confidence interval based on 95% interval and interpret your results. So for that, first we will go back and actually go to the Excel file that was given to us, which is CHF data, congestive heart failure data set, and it's already open for me here. Now what I will need to do is actually to create, like what we did in a previous lecture, we needed to create a variable. We will call it routine. So we'll say routine discharge. So if the discharge was equal to 0, 1, that's basically the routine or discharge home, routine home, then it's going to be 1, otherwise it's going to be 0. So I'll create this guy. So now I have this result done for me. So what is the question here? It's asking me to do. They want me to see, they want me to calculate the routine discharge rate for this sample. So let's create a pivot table I want to create I'll create DRG. So DRG code, I'll put it in the rows, and then the routine, I'll put it in the values. This is a different way to do it, and then I will just say here average, because I already coded it as binary 0 and 1. Now I have actually the percentage for 293 DRG. Is that what it is asking? So I have it here as 0.358, or basically 35.8%. That's my rate for my sample, or the proportion for my sample. Now for the population, it is asking me actually to calculate the national or the US routine discharge rate. So I will need to go to HCOP website, and then we will do like what we did in a previous lecture. Just go through the national statistics on all states. And then I will go select the researchers, and then I will select statistics on specific diagnosis 2013, and then DRG groups, and then all discharges, and then it is 293. So that's what I'm interested in. I will select next. Now it is asking me to calculate the rate for discharges and discharge status, which is going to be the routine discharge status, and then it's asking me for the Medicare, means payer is part of the Medicare. I'll accept, and I will use the first table as we talked about. Second table is standard errors. We're not interested in that. We're interested in the first table where it says Medicare, and we are interested in routine discharge. So basically this number we are interested in. Alright, so now I have identified the routine discharge, and I have identified also the sample proportion and the standard proportion. So all I need to do now is to go to the calculator that we have, where it says here confidence interval calculation. So I need where it says sample. So for the sample proportion, I will put 0.358. Alright, that's the sample, the standard. Now let's go and look at the standard. The standard is point, so make sure that you use the fraction, not the whole number. So you use 0.5644. That's the standard. And what was my sample size? So now I need to calculate the sample size. So to calculate the sample size, you can actually easily calculate that by, you can just put DRG maybe here, and then count. So now I have the sample size for 293. So 81 for the sample size. I think now we are ready. Here we go. So now we can conclude, we can say, based on the sample that we calculated here using our Excel, we are 95% sure or confident that the true population rate is between, in this case it is between 25% and 46%. So as you notice that the larger the sample size, the smaller the interval is, the upper versus the lower interval. So basically that's how we interpret or calculate and also interpret the confidence interval. Very straightforward, very simple. Now let's go on and continue. So we have done that exercise. Now we will continue and talk two-sample z-test for proportions. So the two-sample z-test for proportion is very similar to what we covered in the previous lecture on Monday, where we covered one sample z-test for proportion. So in the previous lecture, we looked at only one sample at our hand, and we compared that to a standard. That was the national standard, for example. But today we will talk about two-sample z-test or z-test for proportions, meaning that we will have two samples at our hand. We will need to calculate the two samples using Excel in our case, and we will need to compare them and find if there is a significant difference between sample 1 and sample 2, proportion for sample 1 and proportion for sample 2. So we say the proportion and rate are used interchangeably. So, and also the hypothesis testing steps, we will use the same hypothesis testing steps, the 5 steps that we have talked about earlier. Another thing that we need to keep in mind is we need to decide whether this hypothesis is two-sided, means two-tailed, or one-tailed or one-sided. It's very important to make that distinction between those. So we said, if our question or our alternative hypothesis is saying that, is there a significant difference between proportion A and proportion B, then it is two-sided hypothesis, because we are not saying is hypothesis A greater or lower than proportion B. So now if we say it's just different, we didn't decide, we didn't indicate whether it is lower or upper or more, then we are going to consider that two-sided hypothesis. But if it is already telling us the direction, whether it is going to be lower or more, proportion A is going to be more than proportion B, then it is one-sided, because it's already told us the direction. So I hope that's clear. I've talked about it in previous lecture, but it's good to refresh. So now we will look at kind of the function or the formula that was given to us to calculate the z-test for two samples. And this also is provided to you in the calculator that I provided to you. So we don't need to worry about putting this formula into Excel. It's already done for you. So what is really important is to understand how to calculate it using that Excel tool that was already given to you. Basically, just plug in the numbers and be able to interpret the results. That's all that is needed. So now let's look at this example here. It is given us two samples. So it is given us the sample sizes for two DRGs. For basically DRG for the heart failure, DRG 291 and DRG 293, and they give us the sample or the sample size for DRG 291 and sample size for DRG 293, and they also gave us the death or the mortality rate. So how many people were dead when they were discharged for DRG 291, and how many people were dead or discharged dead when for DRG 293. So as you can see here, we have the proportion for the sample A, and we have proportion for sample B, and we have the sample size for proportion A and proportion B. So now we will just need to test, and by looking at the question first, we will be able to answer this scenario or this question. So here it is asking us, is the mortality rate for DRG 291, which is this one, different from that in DRG 293? So here the keyword is different. So that means it is one-sided or two-sided. Think about it, pause and think about it. and tell me, is it one-sided or two-sided? If you say two-sided, then pat on your back, and so you did well. Yes, it is two-sided because we didn't decide whether it is greater or lower. Which one is greater or lower? We just said, are they different? We don't mind whether they are lower or higher. So now to answer this question, we will need to go through the hypothesis testing. So I will go to the calculator, and I already have kind of given to you here the template for the hypothesis. So to answer any question, it is best to use this template, and it is very important that we start by having by following those steps step by step, because if you follow those step by step, you will never make any mistake, because you will always be correct, because you are actually having attention to detail. And if you state your null hypothesis and alternative hypothesis correctly and follow the steps, you will always get it right. So now our null hypothesis says there is no significant difference between DRG or mortality rate for DRG 291 and for 293. So you can put that like what they did it, or they put it here. They put 80 actually as proportion 1 equals, means they are not different. If we say they are equal, that means they are not different. So equals proportion 2. On the other hand, the alternative hypothesis says there is a significant difference between mortality rate for, so I'll just do the same here, and then I will adjust the alternative hypothesis to say here they are not equal. All right, so very simple, very straightforward. This will help me after I make my conclusion here. After I look at the p-value, I will say if I reject the null hypothesis, then I will just copy and paste this guy to my conclusion. That will be my conclusion. If I didn't reject the null hypothesis, then I will just copy and paste the null hypothesis, and that will be my conclusion. Very straightforward, easy. Now the alpha level, as we said, the rule of thumb is 0.05, but we need to keep in mind that it is two-sided. Now we will need to calculate the z-test, or the z-test, or the test statistic. In our case, the test statistic is z-test, and to do that we will need to use the calculator. So for the calculator, it is asking me to put the proportion for 291. Proportion 1 is 291. What was the proportion? As you can see there, it is saying it is 0.05%, means 0.0545, right? And then proportion 2, it says it is 0.0109. Now sample size for sample 1 is 360,972. Now sample size for the second sample, which is 293, is sample size, as you can see here, the total number of discharges. That's what I'm getting them from, 197734. I'll just plug in those numbers. Now I got the z-score. Z-score is 80. So in this case, since I know the z-score, I'll just put it here. Actually, I'll put it here. Z-score is 80. All right, 80 point, whatever number that was. So 80.4. All right, now I need to calculate the p-value based on the p-value website, the calculator for us from here. So I have 80.4, and I need to make sure that could select, so 0.05, that's our rule of thumb, significance level, and two-tailed. We already decided about that. Now this is the p-value that I got. So now I'll just put the p-value here. So it isn't blue, means telling me that the p-value is very low, and it's already 0.000. That means it is very low. So if the p is low, then the null must go. So if the null is gone, then the alternative will stay, right? So then we can conclude that there is a significant difference between mortality rate for 291 and 293, right? Simple, straightforward, right? So very easy. Now we'll continue and see if we can do another example by using our own. So yeah, I would not those are kind of might be a little bit different, but the way I am showing you is the easiest way and the shortest way that you can follow. Now let's do this in-class exercise together. It is asking you to perform a hypothesis test to determine if the emergency admission or the source of admission that was emergency room rate for DRG 292 and DRG 293 are statistically different. So here the keyword is different, so that means it is two-sided. And we already have the Excel sheet here for us. So the CHF is the Excel sheet, that the data set that we will use to calculate the ER source of admission. So this is the data set. Now it is asking us to see ER admission, source of admission. So ER source of admission. ER source of admission. For this, in this case, source of admission will be found at data documentation link. Let's say that I don't remember what emergency room source of admission is, so I will just Control F and then put source of admission, and here it is. Now I will see what is the source of admission that was emergency room. So code number 7. So in this case I will need to create a new column for emergency room as a binary variable. So I'll say if source or admission source equals, since it is numeric, it's not as text, those cells, so I will not put quotation marks. So if column G, or the cell in column G, equals 7, then I'll code it as 1. If not, then I'll code it as 0. Alright, so now I have my emergency column. Now it is wanting me to see if there is a significant difference between those two codes, 292 and 293. So let me calculate the rates, because I will need the rates and the sample size. So I will use pivot table. Now I'll drag this DRG codes into the row. Just helps me identify DRGs, and then I will drag ER to the column, and then I can drag either the ID, patient ID, or DRG code into the values. Nope, actually not. What I will do, because I'm interested in the percentage, or basically the rates. One way, there are so many ways you can calculate the percentage, but the easiest way is to get the ER again into the values and put it as average. It will give you here actually You don't even need this column. So you can just use that one. Average ER is there for us. And what else do we need? So one is for the average, and we need also to know the total, how many there were, the count basically, or the sample size for each. So now we have sum. For us, we want it to be count. So make sure that you have those. Count for each of the DRGs. Those are the numbers that we are interested in. And let's go back here, 292 and 293. So those are the ones that we are interested in. All right, maybe you can just put them in different colors, that way we have our sample. We can call this proportion A, proportion, or proportion 1, proportion 2. All right, so now we have our proportions. All we will need to do now is to use the calculator. But before we do that, we will need to put it in a hypothesis testing. So for this one, it is asking us to see if there is a significant difference between ER admission rate for the RG 292 and 293. So the null hypothesis in our case here, we will say the null hypothesis is there is no significant difference between ER admission rate for 292, or means DRG 292 and DRG 293. So proportion 1 is equal to proportion 2, means they are not different, right? And then for the hypothesis, the alternative hypothesis is, it says there is no, or there is a significant difference between ER admission, so ER admission rate for 290, 92 and 293 done for us. So now I will need to calculate the Z, and I will need to calculate the p-value based on the Z. So to do that, I will just need to plug in. I'll plug in here proportion. So the proportion for 1 will be, in our case here, 0.403. Let's do that. And then proportion 2 is 0.531. And then for n, sample size for sample 1, it is 144, right? And then the n2, sample size for n2 is 81. Now this is what I got, 1.8. So let's see here, 92, yep. So I got 1.85, 1.85. So let's see, in this case I will just go to the calculator that we have identified here, p-value for z-score, and I will put this z-score that we just got. So put it first here. So the z-score we got here is negative 1.85. What is the p-value for it, equivalent to it? I'll just plug it in here, negative 1.85. Now it is two-tailed, yes, and then I'll calculate, and this is what I got here. That's the p-value. It is high, so it is even in red telling me that the p-value is high. So if the p is not low, then the null must not go. So that means if it didn't go, then it will stay. So then my answer will be the null. My conclusion will be, actually, I don't have to put null like this. We can just say my conclusion is there is no significant difference between ER admission rate for DRG 292 and for DRG 293. Basically, that's all that we needed to do, and that's straightforward. So in conclusion, actually what we have learned today is we have learned how to calculate confidence interval for proportions, and we also learned how to use two-sample z-test to compare the proportions for two samples and whether they are different or not using Excel. So that was all, and good luck to you.